Note card 18 is a review of several things from algebra. We'll just start off with number 1. We've got slope, also known as rise over run. Number 2 says that slope between 2 points such as x1, y1, and x2, y2 is this formula here. And I will be working an example here in just a second. Number 3, the slope is called the rate of change or average rate of change. The average rate of change between 2 points, this right here is new. This is not review. You probably have never seen it look like this before. 2 points where you have a comma f of a. What does that mean? All this means is it's the same thing if I had x comma f of x. We talked about within the last few weeks or months, last month or two, that if you have an x value, this is the independent value, and that this f of x simply means y. And another way to read it is, what is y when x is a certain number? Okay, so f of x is simply y, x is x. So here in this case, we have the a is the independent value, and f of a simply means what's the dependent value when a is a specific number. So we have a comma f of a, or a comma f of a. In other words, it's just like an x comma y. Same over here, we have b comma f of b, which is simply again another x comma y, two ordered pairs. B is the independent variable, f of b is the dependent variable. Okay, and so it says that the average rate of change between these 2 points is basically f of b minus f of a over b minus a. Or in other words, when b is a certain number, what's its corresponding y value? Minus, when a is a certain number, what's its corresponding y value or dependent value? And then divided by the difference of b minus a. Number 4, the slope of a horizontal line is 0. That's a line that goes from side to side. That slope is 0. It says the slope of a vertical line has no slope. I would prefer, instead of you say no slope, I would prefer you say undefined. Vertical line is straight up and down, and its slope, even though my line isn't perfect there, its slope is undefined. To say no slope is okay. It's just I associate no slope with 0. If I tell you I have no money, it means I have 0 money. It's kind of the same thing. So let's refer to the slope of a vertical line as undefined. Number 5, again, this is something new. It says slope is equal to, and you've got this weird looking notation here. Well, over here is a side note that tells you what it is. These little triangles are basically they're read as delta, and that's what you'll say. This is actually delta y over delta x, which means the change in the y values over the change in x values. In other words, it's the exact same thing as the slope formula you're familiar with. This is just a new notation you'll see in pre-cal and calculus. Up here in your slope formula that you're familiar with, you have y2 minus y1. That's still the change in y's. And over x2 minus x1, that's the change in x. Well, this is kind of a shorter version. Change in y over change in x. Now actually getting to the equations of a line. Number 5 is the one that you're probably most familiar with and the one you'll probably use the most. It's the slope-intercept form. And the reason why it's called the slope-intercept form is because you have a slope m and you have a y-intercept b. So we have a slope-intercept. Okay. Number 6, you have the general form, which you've seen before. Probably the one you're less familiar with, probably one that you've used the least amount of times. You have ax plus by minus c equals 0. And you have the same components here in this formula as you do above. C is your constant term. B is just the number in front of y, or its coefficient, and A is a number in front of x and its coefficient. Now there's a couple of rules here when you're dealing with the general form of a line. If I ask you to write an equation of a line using the general form, the first thing is that A cannot be negative, and also you can have no fractions. I'm sure my English can use a little work there. I probably should say can't have fractions, but this will work. So that's just kind of an overview of that. I'm going to do an example of that as well. 7, you have the point slope form, and you typically use this form when you have a point that you're given and you know the slope. You can find the equation of the line using the point slope form of the line. Remember, if you have a point that's an x1, y1, well, notice you have an x1 here and a y1 here, and then the slope that you know, m, goes here. And you can manipulate and solve for y and put it in slope-intercept form, or you can put it in general form. Or you could, at times, you could possibly even leave it in this form. Number 8, something that probably most of you remember is that parallel lines have the same slope. That's very important to know. And 9, some of you might remember, but it's a little bit more difficult, is that perpendicular lines have negative reciprocal slopes or opposite reciprocal slopes. And the example of that is if one line's slope is 2, then its perpendicular line, the line that's perpendicular to it, its slope is negative 1 over 2. Because you can write 2 as 2 over 1, and its opposite reciprocal is negative 1 over 2, which is where we get the slope of its perpendicular line. Now quickly, to come up with an example that we can work, this is going to come from the handout that I gave you. If we have 2 points, I'm going to use these 2 points to try to work an example that will fit all of these different descriptions here except for 8 and 9. I won't give an example today of 2 lines that are parallel or 2 lines that are perpendicular. You just need to know that parallel lines, their slopes are exactly the same. And you need to know that perpendicular lines, their slopes are opposite reciprocals. But if I wanted to take these 2 points and I wanted to write an equation of a line in slope-intercept form, this is how I would do it. The first thing I would have to do is I would have to find the slope. And my slope formula, m, is y2 minus y1 over x2 minus x1. So we have 2 points, and it's completely up to you how you label these. I always say just work from left to right the way they're given to you. You have an xy, you have an xy for both ordered pairs. So what I would recommend is the first one you have, label that one x1, y1. That's your first x and your first y. Then over here you have your x2 and y2. Now it's important to know that it doesn't matter. You could have chosen this first ordered pair to be x2, y2. It's totally up to you as long as your 1's go with each other and your 2's go with each other. I just recommend we learn how to read from left to right, so work your math here in this case from left to right. So now all you have to do is simply plug everything in. You have y2 minus y1. That's going to be negative 1 minus 5 over x2 minus x1. That's going to be 2 minus negative 1, which gives me negative 1 minus 5 is negative 6, and 2 minus negative, this minus negative becomes a plus. So 2 plus 1 is 3, and negative 6 over 2 is, negative 6 over 3 is negative 2. So my slope, or m, is negative 2. Now I'm going to work a little bit backwards here. I'm going to start with, since I found this slope, I'm going to start with this point slope form. The reason I'm going to start with the point slope form is because most people start there and you can start from here and you can write the equation of a line in either the point slope form, the slope intercept form, or the general form. So I'm going to do both, and I'm going to start with point slope. So using point slope, I have y minus y1 equals m times x minus x1. So now, if I wanted to write the equation of a line in slope-intercept form, I need to know an x1, y1, and a slope. Well, we have an x1, y1 here, and you could use this point. I will point out that you could also use this point. It doesn't matter. Okay? But you need to have one point that exists on that line. Or, in other words, you need to have one set of ordered pairs that is on that line, and its slope. And the way it works, I just plug it in. I have y minus, what is y1? y1 is 5, equals m. M is my slope. I determine that that's negative 2, times x minus x1, which is negative 1. Now notice that when we're working with the point slope formula, this y, this x does not change. Those will stay there. The only thing that will change will be the x1, y1, and the m. You're only plugging in that one ordered pair, the x1, comma y1, and m, your slope. Now from this point, I can distribute the negative 2 and add 5 to both sides, and I could have this solved for y, which means it will be in the slope-intercept form right here. I could easily do that. And so the way it would work is just distribute, and you get negative 2 times x, negative 2x. This minus a negative here again becomes a plus, and negative 2 times 1 is minus 2. Bring the rest down just like I'm solving an equation for a variable. I'm solving for y. Add 5 to both sides. Hopefully you know that you can't add 5 to this negative 2x. They're not like terms. So you have y equals negative 2x, and the negative 2 plus 5 is positive 3. That would be your answer if I was asking you to write the equation in slope intercept form. Okay? If I wanted you to write it in standard form, you would have to take a couple of different steps. So let's pretend for a second, and let's go back to this y minus 5 equals negative 2 times x plus 1. And I'm going to go ahead and make that a plus because we determined the minus and negative was a plus. Now what I'm going to do here is I'm going to write, maybe the directions tell you to write this equation of a line in standard form. And so when I'm working with standard form, remember you cannot have, a can't be negative, and you cannot have fractions. Okay? So what you want to do here is you want to manipulate this in such a way that first of all, on the right side of the equal sign, you're going to have a 0. In other words, you're going to take everything away from the right side of the equal sign. And then you want to have all of your x's plus or minus all of your y's, and then all of your constants on the left side of the equal sign. Another way you might see this in the future is ax plus by equals c. So you might see that too, but today we're going to set it equal to 0. So the way it works is I'm just going to simplify, and I'm going to use my algebra skills to get all my x's and all my y's and my c on the left side of the equal sign. Should be pretty easy. Distribute the minus 2, and I have y minus 5 equals negative 2x minus 2. Then I'm going to move my x's to the left side of the equal sign, and I'm going to do it one step at a time. If you wanted to do both, you could. So right now I have 2x plus y, because it's positive, minus 5 equals negative 2. Then I add 2 to each side. and I get 2x plus y minus 3 equals 0. And that would be your answer in standard form. And I'm good here because I have no fractions, and a, the term in front of x, is positive. Okay? This is a form that you need to pay very close attention to. Just follow those rules. It's not hard. Sometimes people struggle with it, but I'm not sure why. Just manipulate either your x's, your y's, and your constants to go to the left side of the equal side. Remember that when you're working an equation, solving an equation, or manipulating an equation, what you do to one side you have to do to the other, so it's pretty simple there. And that's basically a quick review on how to write equations of lines and how to find your slope.